Okay, let's talk about the review for the first test, second 6 weeks pre-cal. These first 7 things here are just things that you need to be able to do in order to be able to be successful on this test. You need to be able to factor. We're going to talk about all that. We're going to graph piecewise functions. We're going to work with linear function concepts, such as you may have to find the slope. You may have to write the equation of a line in slope-intercept form. You may have to put it in point slope form. You may even have to do standard form and then the linear regression. We're also going to have to find a polynomial equation in factored form. We're going to have to sketch those functions as well. You're going to have to know the difference between real and imaginary zeros. And we're also going to talk about maxima and minima. That's all the stuff that we've covered this chapter. So starting out, looking at our factoring part here, I'll work out a couple of problems, kind of get you started. Okay, this one right here, I'm going to start with E because this seems to be a place where people get confused. What you should be able to look at this problem and tell that this was a grouping problem like F. It started out like F, where you had to group the first two with the last two. And when you do that, when I group this first two, I take out the GCF, which between x cubed and x squared, the GCF is x squared. Because you look at the variable that they have in common, you take the lowest power. So I pull out an x squared out of the first one, which means I'm dividing this and this by x squared, which gives me x minus 1 left over on the inside. Then in the second group, I'm going to pull out a 2, and when I divide these two terms by 2, you get x minus 1. And see, here is the part where these two are similar. Notice this this set of parentheses matches this set of parentheses. Let's go back to E really quick. This set matches this set. So this problem for E, it's already mostly completed. So to complete it with this one, what matches in the parentheses, that's in your answer once, 3x plus 1. And then what's on the outside, 2x minus 3. And this is your answer. So from here it will be x squared plus 2 and x minus 1. Now, I gave you a lot of factoring practice, so you need to make sure you have all that done. Okay, so that's grouping. A is a GCF problem. I'm sorry, GCF. And then let's see, B. Well, it looks like just trinomial factoring, but what you have to remember is before you factor anything, you always want to look to see if you can take out the greatest common factor, because even like in this case, you can't even begin it without taking out the GCF. You got to take out an x because there's an x here, an x here, and an x here. So if I pull out an x here, I'm left on the inside of my parentheses with x squared minus 6x plus 9. And now I can just factor this inside like a regular trinomial factoring or Mustang factoring method. And I think we've covered that enough that I probably don't have to go over that again. So make sure you do try to take out the greatest common factor, the GCF. Looking really quick at H, you should be able to see that this is a difference of cubes. You have x cubed minus 3 cubed. And then if you look at for regular pre-cal, you will be able to use your note card notebook. Pre-AP pre-cal, sorry, you cannot. If you look at the formula for the shortcut or formula, whatever you want to call it, for factoring this difference of cubes, it's going to be if you have a cubed minus b cubed, the factored form is a minus b times a squared plus ab plus b squared. So this one would work out as the first term, or a, is x, and the second term, or b, is 3. So it's x minus 3, x squared, plus 3x, plus 9, because 3 squared is 9, and this is my factored answer. One more problem. If I look at k, again, I'm going to look to see if I can take out a GCF first, and I can pull out a 4. That leaves me with x to the 4th minus 16 inside, which is the difference of squares in here. Hopefully you can see that that's going to be 4 times x squared plus 4, x squared minus 4, difference of squares, and then I have the difference of squares again. So this becomes, the 4 stays there, x squared plus 4, that's prime, this piece is. This is not the difference of squares. And I know some of you might struggle with that. This is a perfect square, 4 is a perfect square, but this is a sum, it's not a difference. And then this becomes x plus 2 and x minus 2. And that's my answer. This is my factored answer here. So that's a quick review on factoring. We've done a lot of factoring in the last couple of weeks. You should be ready on factoring. Looking at number 2 here, we have to we have to write the equation in factored form of these polynomials here. I'm going to work this one here, the third from the left. And it also says to find the leading coefficient if a point on the graph is given. This point needs to be a point that's not a 0 or an x-intercept or a root. Now all those things are the same, okay, but they can't be those. So this graph right here, I am given a point on the graph other than an x-intercept, this 1, 2, so I will be able to find the leading coefficient. So let's look at this. First, let's just look at the factored form. You should be able to tell that since the graph drops or falls from the left and it bounces off the x-axis here, that at x equals -3, you should tell that that's a double root because it bounces. Also, when it comes down and it bounces again off of x equals 0, that's also a double root because it bounces. And then finally, my last root is 3, and that's just going to be a single root. And the difference, what that means is that when you write the equation, since it's a double root, that's going to be a squared term. And remember that when you write your equations, when you actually write the equation y equals, when you write these, you're going to change the sign. So the root here is -3. You write it as x plus 3. And it's squared because it is a double root. Then you have this root here, this double root at x equals 0. That is just written as x squared. Okay? So really quick, kind of bouncing back and forth here. This is a double root at x equals 0, so it's x squared. No plus or minus in parentheses with it because it's not shifted left or right. It's right there at x equals 0. Right here on this one, this is a single root at x equals 0, so it will have just an x term by itself. Now whatever else it has out there, it's going to have, this is represented just by an x. But this double root at x equals 0 is represented as x squared because it's a double root. And then finally I have a single root here at x minus 3. And so this is everything except for the leading coefficient. So if I wasn't given this extra point here, I would be done. But since I'm given this point, I can find the leading coefficient, and we'll call that coefficient A. So I need to find what A is. Well, how I do that, I take this point that I'm given, it has an x and a y value. I plug y, 2 in for y, 1 in for x, and I'll solve for a. So if y is 2, I have 2 equals a times 1 squared, because x is 1, 1 squared, and then I have 1 plus 3 squared, and then 1 minus 3. Then I'm just simplifying a very simple equation here, and I'm going to solve for a. So I have 2 equals a times, and I'm going to use little dots for multiplication. 1 squared is 1 times 1 plus 3 is 4, 4 squared is 16, times 1 minus 3 is negative 2. Continuing, I get 1 times 16 is 16, and 16 times negative 32, or 16 times negative 2 is negative 32, and negative 32 times a is negative 32a. Bring it up here, give myself a little more room. So I have 2 equals negative 32a. And then I just divide by negative 32, divide by negative 32, these cancel, and I get that a is negative 1 over 16. Because 2 is a common factor, that's how that fraction reduces. So what do I do with that? Just come right back up here with my equation where I had it, and I replace a with negative 1 over 16. So my equation is y equals negative 1 over 16 x squared x plus 3 squared and x minus 3. And this is my answer. Now there's a lot of steps there, but it's not too bad. Let's look really quick at this second graph. We've talked about double roots and single roots. If we look here at this graph as it's approaching the x-axis, it flattens out and then goes the other way. This is a triple root, and it would be a cubed factor. So right here, since this is a plus 2, this part of my equation is going to be x minus 2 cubed. Moving on. Number 3, we have to actually sketch these. Before you can sketch these, they have to be in factored form. So A is in factored form, B is in factored form. I'm going to do C since it's not in factored form. I first have to factor this. So I have the difference of squares, but I can first take out an x squared. So if I pull out an x squared, it'll be x squared minus 9 inside. I again have the difference of squares. X squared, x plus 3, x minus 3. So what does this mean? This means that I have a double root, because of the squared term there, at x equals 0. I have a single root at x equals negative 3, and I also have a single at x equals positive 3. Remember, you're changing your signs from the equation to the graph and from the graph to the equation. So how do I graph this? Well, the first thing I have to know is that what we have is a quartic function. I know we have a quartic function because back up here, right here, it tells me the highest power is 4. But if I was given the factored form here, I see that there's 2 x's, 3 x's, 4 x's. So it's still a quartic function. And the reason I need to know that is because if you look at note card 28 where it talks about end behavior, you have to be able to tell whether the function falls from the left or rises from the left in order to graph it. I can tell you right now, since I have a root at 0, I can mark that little spot. I have a root at negative 3, I can mark that little spot. And I have a root at positive 3, so I can mark that little spot. Then when I go to my in behavior, because I have to know, am I going to rise from the left or am I going to fall from the left? I have to know where I start. And so I go to my note card, 28, in behavior, and it has a little chart where it tells you the highest power, 4, is even. It's positive out front. And if I look at that, it tells me on that note card that it falls from the left. So I start here. Now, if it's going to fall from the left, -3 is a single root, so it goes straight through it. Comes back up. At 0, it's a double root, so it bounces off. This is a bounce. So it's going to bounce off of there, and then it's going to go back through the 3 as a single root, and there's your quartic function. And you should know that's a quartic function. It has that W-looking shape. That's how you do those. Number 4, I'm going to leave that alone. I'm not going to be talking to regular pre-cal about tangent lines right now. Number 5 says, sketch a quartic function with 2 real zeros. Real zeros means it crosses the x-axis. So if I want to do a quartic function, I know it's got that W-looking shape. Now that's a positive one. It could also have that W-looking shape upside down. But if I want 2 real zeros, here's a real easy way to do it. There's one. There's one. Done. I could have done it a different way, but that's one way to do it. Another way I could have done it is there's 1, there's 2, and then these last 2 kind of go up like that. I've got 2 real zeros. 1 there, and I've got 1 there. I'm going to leave B to you. We want a cubic function that has 1 real zero. Remember that cubic function has to have this basic shape. You have to remember those parent functions, those basic shapes. Graphing this problem right here, let's look at it a little bit. I told regular pre-cal to change this problem slightly. Instead of having this as 2x minus 1, I changed it to simply x. Okay? So what I have here quickly, you have to remember the square root function. You should know right now that the square root function, it has a point at 0, 0. It has a point at 1, 1. So if this is 1, 1 on the x-axis, or on the y-axis, this is 1 on the x-axis, there's point 1, 1. And it also has the point 4, 2. And that'll kind of get you started there and get you that shape for that square root function. And then y equals x, that's that straight line that has a slope of 1. Actually, I don't want to do that. Alright, I'll leave it like that. Slope of 1, and it works like that. Okay, and then x squared, it has 1, 1. It has 2, 4, and -2, 4, and -1, 1. So it has these points on it. And it looks like that. Now pre-AP, you would have everything here except for the line x. You would have 2x minus 1. So what happens here? Well, for the square root function, I only want the portion of that function where x is greater than 0, and that's exactly what I have sketched here. This piece right here. And so I just leave that. It's where x is greater than 0. Now, there would be an open circle here. It'll be open because of the fact that it's just x greater than, not or equal to. And then for the line y equals x, this line here, I can't erase it because I made this bold line. So I hope you can just see what I'm going to do here. I'll try to figure something out. It's only from where x is greater than -2 and less than 0. So that's back here, greater than -2 and less than 0. So what I've got is all this stuff up here. I don't want this. I only want it, this line, where x goes from -2 to 0. That's down here. And it's going to be just this portion right here. And it's also going to have an open circle here because it's greater than 2 and less than 0. So this is still open right now. And then where x squared, my parabola, I only want that where x is less than -2. So that's only this portion up here. So all the rest of this stuff, all this stuff is gone on my parabola. So the way I would do this problem is I'd graph it lightly first with pencil. And then I would erase away the portions that I don't want. And that's what it looks like. Number 7, we're working backwards with piecewise. You have to look at the graph and actually write the functions. And that's basically it. I'm going to go ahead and let you work on that. Graph those functions. I'll tell you what I'll do. I will start you. What you're doing is you're graphing these functions. This piece, you have 1 piece, 2 pieces, 3 pieces, 4 and 5 pieces. So for f of x, you're going to have these 5 pieces, and you have to write what those pieces are. For example, this first piece, I hope you can see, that's the line -x plus 1. Has a slope of -1, and the y-intercept is +1. So that's -x plus 1. And what's the domain for it? You have to state the domain. We have a closed circle here. Let me erase this and make sure I can see these circles good. I have a closed circle here, so x is going to be greater than or equal to 0 because it's closed on 0, but it's open on 1, so less than 1. And you have to do each one of those. That's the constant function. You have to find 2 points on this line and on this line and use your skills of writing equations of lines to come up with those and stating the appropriate domain. Maxes and mins. Tell where the local maxima and minima occur. When it's asking where they occur, those are the x values. So right here, I have at this point, I have a local max. Traveling down, no more local maxes, no more local maxes. Oh, here I have a local max. Well, where do these local maxes occur? The local maxes occur at x equals -4 and x equals 5. X equals -4 and +5. That's where they occur. What about the minima? I don't have one yet. I don't have one yet. Oh, there's one. I have a local minimum at x equals 2. Have another one right here. Local minimum at x equals 6. Now we're just talking about locals, so I'm not even going to, it's not asking for absolute, but if I was asking for absolute, This one is the highest point on the graph. It's absolute. This is the lowest point on the graph. It's the absolute. Okay? A local minimum or maximum can be an absolute minimum or maximum. Tell where the maximum and minimum values, or tell the maximum and minimum values. What that is the corresponding y value. So this local max is at 2. At y equals 2 and 3. Local min at y equals -2 and 0. That's how those work. So they exist at the x values, but they are actually the y values. Now remember, if this arrow were going up forever, there would be no absolute max. And if this arrow were going down forever, there would be no absolute min. Okay? Number 9, graph the following on a graphing calculator and find the absolute maximum and minimum on the interval from -10 to 10. We do need to talk about this quickly. Bring my calculator up. Okay. We got -3x to the 4th -3x to the 4th minus 5x to the 3rd plus 15x squared minus 5x plus 19. Okay, so this is telling me to find the absolute maximum and minimum on the interval from -10 to 10. So what I need to do is go to my window and adjust my intervals here. This obviously wasn't reset, so let me go ahead and I'm going to change my x minimum to -10, my x maximum to 10. I can keep my scales at 0. I'm not sure what this graph is going to look like first, so I'm going to change my y minimum to maybe -500, and we can play with this, and my x maximum at 500, and then graph. And that's not too bad. On this interval, what you should see, since I did change, make sure it did go, my x minimum is -10, my x maximum is +10. That means that this is -10 and this is +10. So my absolute minimum does actually, what I need to find is, does this stop on this interval? And what you should see here is this graph continues on. This graph continues on in a downward direction on this interval from -10 to 10. So the absolute minimum does not exist. Now the absolute maximum, which is the actual highest point on the entire graph, is right here. And so I find that by going second, trace, 4 for maximum. Here's my cursor right here. It's asking for a left bound. So I want to go a little bit to the left of it. How far? Just a few clicks. Right in there is fine, and hit enter. Now it's asking for the right bound. So I want to go a few clicks to the right of it and hit enter. And then guess. And the maximum, the absolute maximum, is 87.017 when I round it to the nearest thousandth place. 87.017. But that's how you would do that. You want to, you can use decimals here. You got to make sure you set your window up. If I tell you to graph a problem like this and I give you an interval that the x's are valid on, or the domain, and so you want to make sure that you put that in there and then look at your graph very carefully. Let's see here. So it gives you a hint, play with the y values until you get the graph with the maximum. You may have not have known to put that y minimum at negative 500 and the y maximum at 500. Just play with it until you get it into focus. Looking at numbers 10 and 11, I'm just going to go ahead and I'll look at number 10 real quick actually. It says to find the given the following equation, find the average rate of change. So when I look at this problem, I have to go to the note card that talks about average rate of change. And let me create a little bit of room here. When you look at that note card, I believe it was the linear functions. I think it was note card 18. If you look at that note card, you'll see that the average rate of change, let's call it rate of change, is f of b minus f of a over b minus a. And so B would be the biggest number or biggest value, and A would be the smallest value, since B comes after A in the alphabet. So if I want to know what this function f of x is 3x minus 2, I want to know the average rate of change between these 2 points. So in this case, B would be 5, and A would be negative 2. So when I plug this in, I would have f of 5 minus f of negative 2 over 5 minus negative 2. Well, this becomes a plus. Okay. F of 5, that's going to be 3 times 5 minus 2. See, f of 5 is equal to 3 times x minus 2. Another review here. Plug the 5 in. 3 times 5 is 15. Then minus 2 is 13. So f of 5 is 13 minus f of negative 2. F of negative 2 is 3 times x minus 2. Plug the negative 2 in. 3 times negative 2 is negative 6. Minus 2 gives me a negative 8. So minus negative 8 over 7. This becomes a plus, which gives me 21 over 7, which gives me 3. Well, some of you may be saying, well, I knew that from the bat because the rate of change, the average rate of change on a linear function here is the slope, the number in front of the x. But this is how you would find that, using the rate of change formula, the average rate of change. This is the answer, 3. Okay, moving on. Number 11, I'm going to let you work with that. We're writing equation of lines. Go back to that podcast that I gave you on doing that. You're going to have to write an equation of line that's parallel and perpendicular to this line. So what you have to do here, quickly kind of setting you up, I'm not going to do the entire thing, is you want to take this equation, 12x plus 3y equals 4, and you want to solve it for y, because when you solve it for y, that puts it in y equals mx plus b format, and that allows you to see your slope. Not even concerned with dividing this by 3 really, because I don't care about the y-intercept. I want to see that this slope is negative 4. So if the slope here is negative 4, when I write an equation that's parallel, this slope has to be negative 4. But when I write the equation of the perpendicular line, this slope has to be 1 over 4, because this 1 over 4 is the opposite reciprocal of negative 4. And so now you have these two slopes that you would want to write the equation using these slopes and this point. And you would be done there. Number 12 says sketch the following linear functions with no calculator. You should see, if I give you a problem like this on a test, I'll give you a graph. Start at the y-intercept, count your slope, negative 1 over 2. That shouldn't be too hard. Here, this is in standard form. I'll show you really quick, very easy way to do this. Find the intercepts. Remember, if you have an intercept, an x-intercept, the x-intercept is that ordered pair where you have some x but y is 0. And then you have the y-intercept is some point where x is 0, and then you have some y value. So graph this using the intercept method. So if I want to find the x-intercept, I make y 0. But if I make y 0, I have 5 times 0 is 0. That cancels. See, if I have 3x plus 5 times 0 equals 10. I have 3x equals 10 divided by 3, and I get that x is equal to 10 thirds or 3 1/3, which means if this is the 3 1/3 mark right there, that's the x-intercept. That's where it crosses the x-axis. To find the y-intercept, make the x 0. So I have 3 times 0 plus 5y equals 10. That cancels, which is 5y equals 10, and y equals 2. So if y is 2, then the y-intercept is right there at 2. And just connect the dots. And I'm done. That's using the intercept method. You could use the intercept method on any one of these. Works pretty easily. And that'll about do it. This last problem is the linear regression. Remember, you cannot, this is the only part on the test tomorrow you'll be able to use the calculator. And I'm going to refer you back to the linear regression podcast that I made for you instead of going back and recreating a new one. Just remember, you put a couple of things. You might forget some steps, so go back to that podcast, but a couple of things. Your x value is going L1, y value is going L2. Adjust your window reflecting your x min, x max that you're given, y min, y max that you're given, and then go through there. Turn on your scatter plot. It's all in that podcast. If you don't remember how to do it, go back to that if you need some help with this. Remember, on the test there will be two portions, non-calculator and calculator. The only part you'll be able to use a calculator on is this linear regression problem. All of your factoring, all of your graphing polynomials, writing equations of polynomials in factored form, all of that stuff is done without a calculator, so make sure you study, and good luck. Stop